properties and theorems that go along with it. Now, I've already given you the properties and theorems all written out. I do want to add some things to the pictures provided. So we're going to use angle pairs today, which is the corresponding angles, same side interior, alternate interior, and alternate exterior. We're going to use those angle pairs to prove lines are parallel, but I want to show you guys some different theorems that we can include in our theorem packets. So theorem 3-8 is the transitive property of parallel lines. Okay, remember transitive allows me to say if A equals B and B equals C, then A equals C. So we're just doing that with actual parallel lines. So if two lines are parallel to the same line, then they are parallel to each other. Makes logical sense, hopefully. Okay, if we drew these out on a coordinate plane, we'd be able to show that all of the lines would have the same slope, so they would never intersect. So let's add some pictures in here. Okay, I'm told if A is parallel to B, so I'm going to add in my little triangles that prove those lines are parallel. And then I'm told B is parallel to C, so I'm going to add another set of triangles. I changed the color so you can see it a little easier. Okay, then A is parallel to C. So in this picture, I know that A is parallel to C. They will never intersect. It ends up allowing that all three lines in the picture are parallel lines. Looking at theorem 3-9, it says if two lines are perpendicular to the same line, then those two lines are parallel to each other. So in this picture, it shows that if A is perpendicular to D and B is perpendicular to D, then these actually end up being parallel lines. So we can include in there that A and B are parallel. That's what we can add into our picture. Theorem 3-10 says is called the perpendicular transversal theorem. If a line is perpendicular to one of two parallel lines, then it is also perpendicular to the other line. So it says this is only true if the lines are on the same plane. That's important. If A is parallel to B, so add in your parallel lines. And C. Oh, so A is parallel to C as well. So you can add in three parallel lines. We also know A is perpendicular to D. Then B must be perpendicular to D and C must be perpendicular to D. So if you are using this as a proof, your if statement allows you to say the reason. This would be your reasoning for that one. So let's actually test out some proofs. Now, remember when we are proving a theorem, I can't use that theorem in the actual proof. So with 14, it says proving 3-8, I cannot use the transitive property of parallel lines. So we actually can use some of our old stuff that we already know. So I'm going to zoom in on 14 and we're going to add some things in here. Remember, add the given statement into your picture so you can see it starting to develop. So D is parallel to E and E is parallel to F. So we're going to create a nice little T-table. Our reasons column will hold all the reasons why we can say these. And our statements are also going to be included. Statement number 1, D is parallel to E and E is parallel to F. Why we can say it is because it was given to us. Now you know a lot more than what you think you might. Okay, with this next one, I'm going to say that the measure of angle 1 plus the measure of angle 2 equals 180. Why I can say that is the same side interior angles postulate. Okay, angle 1 and angle 2, because lines D and E are parallel, they are same side interior. So we can say that they can add up to 180 degrees. Next thing I want to say is angle 2 is congruent to angle 3. And the reason why we can say that is corresponding angles theorem. And this is because, and I'm going to add it in there so you can see it, line E is parallel to F. And I will add in that for 2, we use line D is parallel to E. You do not have to include that in the proofs that you will turn in for any homework assignments. I'm just showing you why we can say these different theorems. Number 4 seems silly, but I need to tell you guys that the measure of angle 2 equals the measure of angle 3. Reason why I can say that is definition of congruent segments. For step 5, I'm going to replace the measure of angle 2 from step 2 with the measure of angle 3 using substitution. So using substitution, I can replace angle 2 with angle 3 based on what we said in step 4. The very last thing I want to say is now that I know angle 1 and 3 add to 180, I can say that line D is parallel to F. Reason why I can say it is the converse, remember that's the word that we use when we're proving parallel lines. It's the converse of the same side interior angles postulate. Yes, these are a lot of steps. Okay, we are proving lines parallel, and if we are proving a theorem, we cannot use that theorem. But this proves that if 2 lines are parallel to the same line, then they are parallel to each other. It'll be a good thing to remember once we get into tougher proofs. Our very last thing to talk about is number 15. We're proving theorem 3-9. In the picture, it has our given statement. We are told that T is perpendicular to N and T is perpendicular to O. So let's create our T table. We're going to have our statements and our reasons. The first thing we can say is the given statement that T is perpendicular to N and T is perpendicular to O. This is the given statement. That's why we can say it. Statement number 2, I know that the measure of angle 1 in the picture is 90 degrees, and I can also add that the measure of angle 2 is 90 degrees. The reason why we can say that is the definition of perpendicular lines. We haven't used this yet. Okay, so the definition of perpendicular lines was in your cheat sheet from a couple weeks ago, and you can include it here. Perpendicular lines allow lines that intersect to be 90 degrees. So if lines are perpendicular, then they can add up to 90 degrees. So we have the measure of angle 1 equals 90, measure of angle 2 equals 90. Now because we can add some shortcuts, I'm going to say that angle 1 is congruent to angle 2. The reason why I can say that is a shortcut that's new to us. I know that right angles are congruent, and this is a right angles congruency theorem. So if 2 angles are right angles, then they are congruent. My very last thing, I'm going to say that N is parallel to O. The reason why we can say that is the converse. It's a converse of the corresponding angles theorem. Okay, remember converse is used to help prove that 2 lines are parallel. Now if we're looking at the entire document, overall what you guys have focused on today